Hi all, welcome back to MATLAB tutorial on Tooth Fulcrum. This session is on the MATLAB Graphics, and here we will be discussing about drawing bar charts, drawing contours and three-dimensional plots that we use in MATLAB. Let's begin by drawing bar charts. The bar command draws a two-dimensional bar chart. Let's take up an example to demonstrate the idea. Let's say we have a classroom with 10 students. We know the percentage of marks obtained by these students. We will draw the bar chart for this data. So let's say we have the count of students or the students. Let's take this as a vector x. So 1 to 10. So we have 10 students. And we know the percentage of marks of these students. So let's take the marks to a variable y. And let's say their marks be 75, 89, 67. So let their marks be as shown to the variable y. To draw the bar chart for this data, we will use the command bar. So bar of, we need to plot between the students and their marks. So we'll say bar of x, y. Now you can label your x-axis and y-axis. For this, we will use the command x label. This will label the x-axis. So whatever label you want to give, you can provide within the quotes. So let's label our x-axis as student. Same way you can label your y-axis as well. So y label, let's label it as marks. Now you could give title to your plot. So the command is title. So what the title do we give? Let's say semester 1. So let this be the semester 1 marks of the students. So we have a bar chart for the students and their corresponding marks. So let's run this and see how the bar chart gets plotted. So you could see the bar graph that is plotted between the student and their marks. So along the x-axis it's labeled as student, and along the y-axis it's the marks, and the title for our plot is semester 1. So if you take this as the student, so first student has acquired a mark of say 75. Second one close to 90. So it is 89. Yes, you could say from here. So this is how you plot a bar graph. Now let's see about drawing contours. A contour line of a function of two variables is a curve along which the function has a constant value. Contour lines are used for creating contour maps by joining points of equivalent evaluation above a given line, such as a mean sea level. MATLAB provides a contour function for drawing contour maps. Let's take an example. Let's generate a contour map that shows the contour lines for a given function g is equal to f of xy. This function has two variables. So we will have to generate two independent variables, that is, two data sets x and y. This is done by calling the mesh grid command. The mesh grid command is used for generate a matrix of elements that give the range over x and y along with the specification of increment in each case. So let's plot a function g is equal to f of xy, where x is varying from -5 to 5 and y varies from -3 to 3. Let's take an increment of 0.1 for both the values. So let's take the variable set as, so let's say x, y equal to, we are going to have a mesh grid. So the command is mesh grid. Now we have to specify the values. So x is ranging from -5 and the step size we have taken it as 0.1 to 5. Comma, now we have to specify for the y-axis. So that is -3. The step size is 0.1, 2, 3. Now what we need to do is, we need to assign the function. So let our function be x squared plus y squared. So let's create a script file and type the code. So g is equal to x squared plus y squared. So now we will use our function contour. Contour of x, y, g. So let's run our code and see our contour map. So you could see the contour map. X varying from -5 to 5 and y varying from -3 to 3. And the equation that we have used here is x squared plus y squared. Now let's see about the three-dimensional plots. So three-dimensional plots basically display a surface defined by a function in two variables. Say g is equal to f of xy. As before, to define g, we first create a set of x, y points over the domain of the function using the mesh grid command. Next, we assign the function itself. Finally, we use the surf command to create a surface plot. So let's start doing. So let's create our mesh grid for two independent variables x, y. So we use the function mesh grid as used before. So let x and y range between -2 to 2 and let the step size be 0.2. Now let's define our g. That is, let's take the function as x into e to the power of -x squared plus y squared. So x into exponent of -x squared plus y squared. Now we will use the surf function to get the 3D plot. So surf of x, y, g. So let's run and see our 3D plot. You can also use the mesh command to generate a three-dimensional surface. However, the surf command displays both the connecting lines and the faces of the surface in color, whereas the mesh command creates a wireframe surface with colored lines connecting the defining points. So this is about the MATLAB graphics. Thank you so much. Please do like, share, comment and subscribe, and please don't forget to tap the bell icon. You'll get notified whenever we upload a new videos. Thank you.